So my mom watches all my videos. She doesn't really know what they mean, but she watches them. And usually I'm talking about serverless. So we got this really cool opportunity a couple months ago to put together a serverless video called Serverless with Mama J, where I explain that. And we've done another one. And this is called Containers with Mama J. So this is the entry 2 of the series. So in this session, we're going to be talking about containers, and we're going to explain them. So come check it out. I hope you enjoy it. So last time we sat down, we talked about serverless. Do you remember that?
I remember Lambda, the restaurant that calls the servers in when the customers show up.
That's exactly right. I'm so proud of you. That's good. All right. So today we're going to talk about something a little different, but still related, and that's containers, and specifically a service called Amazon Elastic Container Service, or ECS. Now, I know you've heard me say the word containers and just kind of smile and nodded at me.
I've heard you say a lot of words, but I do remember you saying that. But I actually thought you were talking about something like Tupperware.
You're actually not far off. Actually, you're closer than you think. So let's get into it. If you want to know more about containers and ECS, come along, join us, and enjoy. So before I explain what containers are, I need to explain the problem they solve, because everything in technology should solve a problem, right?
That makes sense.
Okay. So here's the scenario. Do you remember back in the day, you and I both worked in that office, and we had that server in the back room?
You mean that dinosaur that heated the entire space?
That's right, yeah. This dates how old it was, right? Yeah, that's the one. So imagine this. I'm a developer, imagine that. I'm building a website, I'm building it in my laptop, everything works great. The colors are right, the buttons click, the data saves, it's perfect on my machine.
Okay, I'm imagining that.
Then I take the same code and I put it on the server, the one in the back room, and it breaks. It just doesn't work. Something's different. Maybe a server has a different version of the programming language. Maybe it's missing a library. Maybe it's configured slightly different. But the point is, it worked on my machine and it doesn't work on the server.
So it's simply not compatible.
Yeah, that's exactly right. The compatibility is the issue, and this is the #1 problem developers have dealt with for decades. We even have a joke for it. We say, well, it works on my machine. And that became so famous in the developer world that people made stickers, they made memes, and they made t-shirts.
Oh, like your shirt.
That's right, and like yours.
And this shirt.
That's right, and I made you wear it. I appreciate that. So here's why this is really painful. Let's say you've got a team of 5 developers. That's a 5,
Got it.
right? And one is on a Mac, developer 2 is on Windows, developer 3 is on Linux, and they all have slightly different setups, right?
Okay.
All 5 of them, slightly different versions of things installed, and the server they're deploying to, that's different from all of them.
So everybody's system is different.
Yes, the systems are different, and we use the word environment, right? So when we say environment, I mean all the stuff surrounding your code, the operating system, the tools installed, the versions, the settings, all of that. So the question became, how do we make sure that what I build on my machine runs exactly the same on your machine, on the test server, and in production?
So you need to make them all the same.
Exactly. That's it. That's what containers solve. That's the problem we're taking care of. So let me tell you a quick story. Back in 1956, there was a truck driver from North Carolina named Malcolm McLean.
Okay.
Now, back then, when you ship goods across the ocean, let's say you wanted to send furniture from America to England, here's how it worked. Workers would carry individual items, boxes, barrels, crates, all different shapes and sizes, and they would load them onto the ship by hand, piece by piece.
Oh, that sounds like it would take forever.
It did. Truly, honestly, it would take weeks to load a ship. And when it got to the other side, they unloaded it by hand again, the same way. Things would get lost, damaged, stolen, and every port did it differently. If you had to move cargo from a truck to a ship to a train, every transfer was a mess.
Because nothing was standardized.
Exactly. Nothing was standardized. So Malcolm McLean said, what if we put everything in a standard metal box?
Okay.
Same size, same shape, every time. You pack that box at the warehouse, you put it on a truck, the truck drives to the port, a crane lifts the same box onto the ship. Ships cross the ocean, cranes lifts it off, puts it on another truck, drives it to its destination, and here's the key. You never open the box in between.
Okay, it just became a standard packaging that goes everywhere the same way.
Yes, that's exactly right. And it doesn't matter what's inside. They don't care, right? Could be furniture, could be electronics, could be food. The box is always the same. The ship, the cranes, the trucks, they know how to handle the one standard shape. And this revolutionized global shipping. Loading went from weeks to hours. Costs dropped, and the whole world economy changed because of this one idea.
That's a very clever idea.
Yeah, good on Malcolm, right? All right, so here's the connection. In software, a container is the same concept. You take your application, your code, and you put it in a standard box along with everything it needs. The programming language, the version it needs, the libraries, the tools, the settings, everything goes in the box. And now that box runs the same way whether it's on my laptop, your laptop, a test server, or production server in the cloud.
So it's sort of like packing a suitcase for a trip. Instead of hoping the hotel has everything that you have forgotten or couldn't place, you can get it all in one box.
That's a great way to put it. That's actually really smart. And that suitcase works whether you're staying at a hotel or an Airbnb or your aunt's house.
Even when you pack your favorite pillow?
And I know you do. You have to bring your pillow. And now you know why containers exist. Now, someone watching might say, wait a minute, don't we already have virtual machines? Don't those solve this problem? And that's a fair question. So let me explain the difference. You know the difference between a house and an apartment?
Really? You're asking me that?
Well, yeah, I have to ask. So look at it this way. A virtual machine, or VM, is like a house. It has its own foundation, its own plumbing, its own electrical system, its own heating.
Right.
Everything is separate. Everything is self-contained. It's heavy, it's big, it takes time to build, but it's completely isolated. Okay, you get that. A container is like an apartment. The apartments share the building's foundation, plumbing and electrical grid, but each apartment has its own locked door, its own rooms, its own furniture. You're isolated from your neighbor, but you're sharing the infrastructure underneath. You with me?
So containers are lighter.
Okay, good. Containers are lighter. Yeah, that's a good way to say it. It's much lighter. A virtual machine might take up gigabytes of space because it includes an entire operating system, whereas a container, megabytes. A virtual machine takes minutes to start up. A container, seconds. Sometimes less than a second. And where you might fit 5 or 10 virtual machines on a server, you can fit hundreds of containers.
So it's more efficient.
Yeah, way more efficient. Same isolation, much less waste. So now we know what a container is, but how do you actually make one? This is where Docker comes in. Docker is the tool that made containers easy and popular. It came out in 2013, and as much as I hate to say this as a serverless guy, it basically changed how we build software, and it did.
So Docker is like the loading docks.
Exactly. If you think of the name, that's actually where it comes from. Dock workers who load shipping containers. So with Docker, you do 3 things. First, you write what's called a Docker file. Now you can think of this as kind of like a recipe card.
Like a recipe card in my kitchen?
Yeah, one we never see come to fruition, but yes, that's the one. So step 1 with this is we start with the base. You're looking at this recipe card, we start with the base. Maybe that's start with Node.js environment, which is kind of like saying start with a pre-made pizza dough.
Oh, sure it is.
Step 2, you add your code. That's like adding your toppings, right? Step 3, install your dependencies. Bake at 400 degrees. Step 4, tell it what to do when it starts. Serve on a plate.
Okay, so the Docker file is where you find the instructions.
Yeah, that's exactly right. So now, when you run that recipe or those instructions, you get what's called an image. And this is like an image is like a frozen meal. It's your fully prepared application, frozen in time, ready to go. You can store it, you can copy it, you can share it, but it's not running yet.
Because it's in the freezer.
It's in the freezer, exactly. Now, when you actually want to run that application, you take that image and you create a container from it. That's like taking the frozen meal out of the freezer and microwaving it. And now it's live, it's running, it's doing its thing.
And then you can make multiple meals from the same frozen package, like multiple servings?
Yes, yeah, every analogy can break down a little bit, but that's basically the idea. From one image, you can run 10 containers, 100 containers, or 1,000 containers. They're all identical copies running at the same time.
Okay, I get that.
All right, because you're cruising, you're hanging in there.
Got it.
Yeah. All right, so where do you store those images when you're working at AWS? In something called ECR, or Elastic Container Registry. Think of it as a private warehouse for your container images. Only your team has access to it. It's secure. It even scans your images for vulnerabilities when you upload them. Still with me?
I think I'm keeping up.
So here's where it gets interesting. Running one container on your
That was
laptop.
5.
Today it's 1, right? Running one container on your laptop, easy. Click a button, it's running. But let's talk about the real world where we run a lot more than one.
Okay.
All right. Let's say you're building a big application. We'll do a food delivery app because we like food. Yeah, we're good at those. You've got an order service, a payment service, a driver tracking service, a notification service, a restaurant menu service, and on, right? Okay. Each one is its own container. And you're not running one copy, you're running 5 or 10 copies for each for redundancy. So now you've got maybe 50 containers or maybe even 200 or 1,000 containers running.
That sounds like a lot to keep up with.
It is. That's the truth. And here's what starts happening. Container number 47 crashes at 3 a.m. Who notices? Who restarts it? Traffic spikes because it's Friday night dinner rush. We always order pizza on Friday night at the Johnson house, right? Who adds more containers? Your payment service needs to talk to your order service. How does it find it? They're not always on the same server. What if a server runs out of memory? Where does the next container go?
Well, I guess you need somebody managing all of that.
I don't want to be the one managing it.
Okay.
Truth is, you need a system managing all that. Think of it like this. Do you remember the restaurant analogy from our serverless video?
The one where you call the servers in when needed.
Exactly, right. It was empty, then you call them as they needed. Now think about this one a little differently. If you have one chef in a kitchen, they can handle everything themselves because we've got these servers running. But if you have a kitchen staff of 50 chefs handling a dinner rush at a wedding for 500 guests, you need a head chef. Someone who assigns stations, someone who notices when a cook calls in sick and finds a replacement, someone who routes orders to the right station, someone who adds more cooks during the rush and sends people home when it slows down, someone in charge.
The head chef then is the manager.
That's right. The head chef is the manager, but in the container world, we call it the orchestrator. Okay, so the orchestrator is what manages all your containers. It handles scheduling, the scaling, the health checks, the networks, the load balancing, all of it. Without an orchestrator, once you get past a handful of containers, it's chaos.
Like a kitchen with no one in charge.
That's exactly right. So that brings us to Amazon ECS. Dun, dun, dun. This is the Elastic Container Service. ECS is the head chef. It's AWS's container orchestration service, and it's been running in production since 2014, over a decade with massive companies running their workloads on it.
So ECS keeps everything in order.
Yes, ECS keeps everything in order, and I'm gonna break it down because I know you're dying to understand the pieces, right? First, you have what we call a cluster. Okay. So back to our kitchen, this is our kitchen, right? It's the environment where everything runs. You might have a dev cluster and a production cluster, just like a test kitchen. You have a test kitchen, right?
Oh yeah, test it every day.
Okay, and you have a real kitchen. Then you have a task definition. Remember the recipe card?
Oh, yes, I still remember, son.
Okay, good, good. The Docker file was the recipe for building the image. The task definition is the recipe for running it, right? It says, use this image, give it this much CPU, this much memory, expose this port, use these environment variables. It's the instructions for ECS telling it what to do.
So it's actually telling the head chef what to do.
Exactly. Now, when ECS actually runs one of those, that running instance is what we call a task, right? And the task is the dish being cooked right now. And then you have the service, right? And this is really powerful. A service is a rule that says, I always want 5 copies of this running. If one dies, start a new one. If I need more, scale up. If traffic drops, scale down.
So the service is like the restaurant policy. Always have 5 dishes ready to serve.
Right, that's exactly it. It keeps those policies or keeps those tasks in line. ECS ensures that what you asked for is what's running. If a container crashes, ECS notices, and within seconds, it starts a replacement. If you say, I want 10 copies, ECS makes sure you have 10 copies.
And you don't have to sit there and watch it all the time.
And I don't have to sit there and watch it all the time. That is incredibly important for my nighttime sleep, right?
I know.
ECS does the watching. It does the health checks. It does the restarts. It does the scaling. All the things, right? And you set the rules and ECS follows them.
Got it.
All right. Now, being a serverless guy, this is where things get really cool. So buckle up.
I'm hanging on every word.
I see you are. So let me ask you this. Do you remember with Lambda, when we talked about this last time in serverless, you didn't have to manage the servers?
I do remember that. AWS handles all of that.
AWS handles all that. So with ECS, you have a choice, right? You can run your containers on EC2 instances, which aren't serverless. Those are virtual machines that you manage. You pick the size, you patch them, you deal with them and any changes they need. Or you can use something called Fargate.
What's Fargate?
It sounds like it's out of a sci-fi movie, right? Yeah. Fargate is serverless containers. It's like Uber for your containers. With the EC2 option, you own the car, you maintain it, and you put gas in it. You change the oil, you worry about where to park it. With Fargate, you just say, I need a ride. Here's where I want to go. And AWS provides the compute and runs the container, handles everything underneath.
So I never need to worry about anything in the car.
That's right. Yeah, you don't have to worry about anything. I know you're used to working on your own car. No more. No more, right? You never see the engine. You never change the oil. You just say, I need this much power, run this container, and Fargate handles it for you.
That sounds like what Lambda does.
That's a great observation. It's very similar, and this is important. Lambda and Fargate are both serverless. Woo, we love serverless, right?
Yes, we do.
You don't manage servers with either one, but they serve different purposes, and this is important. Lambda is like a light switch. You flip it on, it does something quick, and it turns off. It's event-driven, short tasks, maximum 15 minutes, and that's by design.
Like those text messages I keep receiving on
You were getting them this morning.
appointments. I got them today.
You get them this morning, right? Exactly. Quick bursts of work, things that need to be sent out and we're done, right? Fargate is more like a restaurant kitchen. It stays open, it can run for hours, days, indefinitely. It's for when you need something continuously running, like a web server that's always accepting requests or a video encoding service that processes a 2-hour movie. Lambda isn't designed to do that.
So Lambda is for quick things and Fargate is for things that need to run all the time.
Nailed it.
So good.
Nailed it.
Got it.
Makes me happy. Lambda goes down to 0. That's an important thing to understand. You pay nothing when nobody's calling. Fargate typically stays running because when you want it ready, you want at least 1 or 2 servers there, right? That's the spectrum. Lambda is a maximum abstraction. Fargate gives you more control while still being serverless. Okay, so it's time to make this real, right? Let's build something you understand. You shop on Amazon.
Yeah, once or twice.
Once or twice. How about once or twice at 2 a.m., yes?
Or 3 or 4.
Or 3 or 4, early mornings, got it. So let's imagine you're building a shopping application like Amazon, but it's a simplified version just for these purposes. When you go to the site, there are several things behind the scenes that are happening. There's a service showing you the product catalog, all the items you can browse, of course. There's a service handling your shopping cart, keeping track of what you're going to buy from us. There's a service processing your payment. That's important. There's a service managing your order shipping, and there's a service sending you notifications your order has shipped. We always like to see that. It's exciting.
That's 5 different things.
It is 5. We're back to 5. That's right. 5 different things, and they all need different things, right? The product catalog just needs to show images and text. That's fairly lightweight. But the payment service, that needs heavy security and compliance. The notification service, well, that spikes when orders go out, but is quiet otherwise. They all have different needs. You see the changes here.
So each one is its own container.
Oh, you're learning. I love it. Okay, each one is its own container. And ECS manages all of them. So your cluster, your kitchen, remember that? Okay.
Got it.
Contains all 5 services. Each service has a task definition, the recipe for how to run it, and each service might have multiple tasks, multiple copies running for redundancy. Now here's the magic. It's Black Friday. You remember we talked about Black Friday? Are you familiar with Black Friday?
Oh, the sites get slammed, I heard.
Get slammed. Nice. That was a good use of the word slammed. Good. Exactly. So on Black Friday, the product catalog is getting hammered. I'll give you a new one. Everyone's browsing. ECS sees the CPU usage is going up and automatically starts to scale from 5 containers to 50. But the notification service, people haven't really used that yet. They haven't ordered yet, so they're still browsing, and it stays at 3 containers. Each service scales independently based on its own demand.
Well, that's actually smart. You don't waste resources on the parts you don't need.
That's exactly right. You're getting it. You're ready to be a solutions architect.
I think so.
I think you're there. So the load balancer, okay, a new term here.
Got it.
Think of this like a hostess at the front of the restaurant, right? It's distributing all those incoming requests evenly across the containers. If one container is unhealthy, someone goes home sick, the load balancer stops sending traffic to it, and ECS starts a replacement immediately.
And nobody that's shopping even notices.
You never saw it happen. We did it right. Yeah. Doesn't interrupt your shopping experience.
That's good.
All right. So nobody notices, and that is the goal. All right. Now, knowing you, I know you're going to ask this question because you asked the same thing last time. What is it?
You're reading my mind. What about security?
Security. Important. Super important. All right. Security. So with containers on ECS, much like the rest of AWS, we take security very seriously. So first thing, every container runs in what we call a VPC, or virtual private cloud. Think of it as your own private gated community. No one from outside can get in unless you explicitly open the gates.
Okay.
Okay, you're with me there. All right, second, every container gets its own role. It's a set of permissions. And here's the principle. We talked about this the other day. We have a principle of what we call least privilege, which means you only get enough access to do what you need to do, nothing more. When a container starts up, it has permission to do nothing, actually. That's how it starts. And you have to explicitly say, this container can read from this database, or this container can write to the storage bucket, nothing more. Least privilege, right? It's like giving each employee in a hospital their own key card that only opens the specific rooms they need to enter.
So the notification service cannot go looking at the payment container's data.
That's exactly right. Yeah. So if you think about this, they're isolated. They can't see each other. They only have access to what they need and what we give them, right? And as far as the data itself, we encrypt the data, both while it's being sent between services and while it's stored in databases. Same 2 types we talked about before, encryption in transit and encryption at rest.
And AWS handles the physical security of where the computers actually are.
Yeah, that's data centers, right? Data centers are a hot topic right now, and for us, they're lockdown, guards, cameras, biometric access, all the things.
Well, that's actually reassuring.
Yeah, we think so. So let me recap what we just covered, because I just threw a lot at you.
You really did.
Okay, you're doing great. So hang on,
Thanks.
just a little longer. All right. So containers solve the it works on my machine problem. You pack your code and everything it needs into one standard box. That box runs the same way everywhere. Like a shipping container on a truck, a ship, or a train, same box, Works everywhere.
The suitcase.
The suitcase, exactly. Then we talked about Docker, a tool for building containers. The Docker file is your recipe card. The image is the frozen meal. The running container is the meal being served.
And ECR is the freezer.
Nailed it. Good job. The warehouse, the freezer, right? Yes. Then we talked about the problem. One container is easy. Hundreds of containers is chaos, right? You need an orchestrator, a head chef.
ECS.
ECS, Elastic Container Services. It manages your containers, keeps them running, scales them up and down, restarts them if they fail. We also talked about Fargate, the serverless option. You don't manage any service, and AWS provides the compute. You just run containers.
Uber for containers.
Uber for containers. And through all of it, security, least privilege, encryption, isolation, private networks.
I think I get it. Containers are the package, ECS is the manager, and Fargate means you don't have to worry about what's underneath.
That's it. I could cry. You're awesome. That's awesome. That's the whole thing.
I think I'm going to explain all of this to my senior adult choir on Monday.
I think they'll love it. I really do. And if you want to learn more about containers and ECS, check out the AWS documentation links below and subscribe to this channel for more videos like this. That's a wrap on containers on ECS with Mama J.
I feel smarter already.
You are smarter. And thanks for watching. We'll see you next time.